Hey everybody, welcome back to the channel. Today in the shop, in the home garage here, I'm going to be setting up the perfect off-road 4-link suspension to make Project Rock Gobbler handle all the power and all the big rocks, maybe even a little bit of speed. I'm going to go over the basics, like a 101 video. I'm going to show you guys how to input your information in the 4-link calculator, but I'm going to give you all the information you need here to set up the perfect 4-link suspension for the rear. Now, I'll make another video about your 4-link suspension in the front pretty soon when I do the front of this CJ. Let's get to it. There's a lot of information when it comes to setting up a 4-link suspension, and it's a little bit different if you're setting it up in the front versus the rear. But today we're going to focus a little bit on the rear. The one thing everybody seems to focus on with their rear 4-link is their anti-squat number. Your anti-squat number basically correlates to what your rear suspension does when you hit the gas. If you have 100% anti-squat, you have no rear squat. And that, while it would be pretty good for a rock crawler only, it's not good for something that's going to be going a little bit faster. For example, a trophy truck in a Baja race. Those vehicles actually don't really have much anti-squat at all because they want super soft suspension to absorb everything, making it feel like you're in a waterbed while you're out there. What no anti-squat does is it actually transfers all of the energy in your rear axle, in your frame, from your motor down to the ground, which is why the suspension's not absorbing any of it. And the angles of your links can totally affect that. And that's where you need to make sure that everything is set up correctly. So Artec Industries makes it pretty simple for you guys to do it with their Easy 4-link kit. Now, I'm gonna use that kit, but that kit was designed for a TJ. And this frame, it's not a TJ frame. This frame's not even a CJ5 frame. This frame is completely custom and I built it off my garage floor. So while I'm going to use the Artec Easy 4-link kit meant for a TJ, it essentially only gives me the tubing, the heims, and the frame side brackets to make this work. Now my frame side brackets, I'm going to have to angle them maybe a little bit and maybe put some plating in there. But we're going to talk about it and I'm going to give you guys the rule of thumb as we go so that we can mock up a 4-link and then plug those numbers into the 4-link calculator before I make it permanent. We'll see what the numbers are, and then we'll know what to adjust. All right, so we got the boy, future here, Warpaint Off-Road. This is what your brackets look like when you sent them from Artec, but you'd have double everything. We're gonna weld it together so that it essentially looks like this. And you see how it kind of keys over the frame over here, and then has a spot for your adjustable uppers, and then your single lower down there. Now, can you see where you're welding? Yeah. Okay, go ahead. Yeah. Good. Now go a little slower, all right? And maybe bring the tip just a touch closer, and now do this side. There you go. Perfect. Yeah. That one was great. Good job, dude. Yeah. So with that bracket in here and nice and cool and ready to go, it's time to basically tack weld on the next piece, and perfect timing here. We're gonna get it started. Now it's basically time to put on the next piece. Now this piece is essentially the bracket for the upper control arms that goes on here, and it kind of just keys into place. It's pretty self-explanatory. So we're gonna key it into place just like that, have her lay some tack welds, I'll finish weld it, and then we'll get to doing the inside. Go for it. Okay, I'll drag it up. The future of Warpaint Off-Road over here. This bracket finish welded, the backside of our next bracket painted, and the inside of this guy painted that we'll never be able to reach again. It's time to throw it in there. This particular bracket does not actually key into place, so you're gonna wanna make sure you maintain the distance that you need between both mounting surfaces. In this case, I'm using an 1.25" heim joint, which is 2.65 inches. Now I can throw the heim joint in there, slide a bolt through it, and then weld it, but I don't want to overheat that heim joint and damage it. and I don't have any old 1¼ Heim joints available. So I took a piece of tubing, cut it, used a grinder. It's 2.65 inches actually with a set of calipers. I'm gonna throw it in there, slide something through the holes, make sure they're all lined up on each other. Basically, tack it into place, and then finish weld it. Then you're gonna follow the same process and the same steps with that lower bracket, finish weld it, let it all cool, and you're ready to move on. So the first thing you're gonna need to know when you're doing your 4-link in your rear is what tire size you are going to put on your rig. The Rock Gobbler has a 43-inch tire, but here's the trick with that. You don't wanna go off the tire size that's labeled on the side of the tire. You actually wanna measure its height. They're never exactly as tall as they say they're gonna be, and we need to know exactly so we can find out what 25% of that height is. It's actually only 42.5 inches, which means 25% of that height is about 10.5 inches. And that translates to our rear brackets on the axle. That basically means you are gonna go from the center line of the axle. Let's just pretend we have an imaginary line going all the way along the center. And the distance from the mounting point of your lower link to the mounting point of your upper link be that 25% number. So mine are actually set perfectly at 10.5 inches. What's really nice about that Artec truss is the fact that it's set up to have those upper links that they also make be 9 inches away from the axle center line. That allowed me to rotate the lower link bracket down just a touch and actually end up with perfect separation. My uppers, those are a little bit adjustable because as we set this up, we're gonna have to think about the triangulation angle and figure that out, maybe make some adjustments. And with these frame brackets now done, I did flip it over and paint the inside. Once I mount them on the frame, I'm not gonna be able to ever paint the inside. You don't want them to rust. On my frame, what I did to add a little bit extra strength is I actually put a sleeve over the actual frame. Now this sleeve was basically just a cap that's made in the perfect diameter and the perfect size to fit over my 2x4-inch tube. I notched around it for the fish plate. It basically fitted on and welded it. That gave me a nice flat surface, even with the fish plate, so I can mount my bracket. So with this painted up too, because again, you'll never have access to it once your bracket's on, just basically gonna slide the bracket into place and put the other one on the other side. Now those brackets are gonna get welded, but of course not right now. It's only mock-up and I need to make sure the rest of my angles for my triangulation are right. Now the key with your uppers on a 4-link is you need them to be exactly the same length. So I'm gonna measure one side. And you're gonna wanna make sure that your axle is obviously centered under the frame. You're also gonna wanna make sure that your bracket is basically centered on the axle and angled where you kinda want it to be. I basically eyeballed mine directly at that bracket, and I'm gonna cut my PVC, do the math, figure it all out, and make a link. I got my driver's side upper basically done. Got my link taped in now. So these brackets from Artec are drilled out for a 9/16, but I told them what I was doing with this rig and they suggested the 1¼ Heim with a 3/4 inch bolt. I don't have my 3/4 inch bolts quite yet, so I went and I bought some wooden dowel. I just cut it off, and that's gonna kind of simulate my bolts at this point, so we can kind of get this guy nice and in there and figure out exactly how it needs to go. So, I'm gonna drop this guy down, slide my dowel in place to kind of hold it in position. Let's do the same thing on this side. Because you already saw me make the PVC links, you don't need to see me take measurements, make more links. It's not that big of a deal. Like I said, I'll show you guys how to do it when it comes time to actually make the steel tube links, because that's a lot more important. So with my uppers being the same length, my lowers being the same length, it sets me up with this triangulation. Basically, for an off-road vehicle, for a rock crawler, rock bouncer type situation, you're looking between 40 and 60 degrees of total triangulation. Now that can get confusing because if you're trying to measure your triangulation and you're measuring this angle, it's gonna be different than that angle, which is gonna be different than those lower angles. So the thing when you look on the internet is no one tells you what your point of reference is. So on your uppers, you're basically measuring the distance of triangulation where they come back to the axle and then V apart from each other toward the frame. We want to know what that angle is. Now, if that's your only point of triangulation because your lowers are parallel to each other, you need between 40 and 60 degrees. And that's pretty tough to get in a factory Jeep frame that's not a tube chassis. It honestly is even tough to get in this because it's designed for a factory Jeep tub. But if your lowers are triangulated in the opposing direction from your uppers, then you need a total of 40 to 60 degrees, adding the upper triangulation and the lower triangulation. I know it can get a little bit confusing, but as long as you're between 40 and 60, you'll have enough for the lateral forces that'll be on an axle with a lot of horsepower, big tire, off-road. And as long as your upper links are parallel and your lower links are at less than 10 degrees angle from the axle up to the frame, that's pretty much all you need, and you'll probably have a pretty good number in the 4-link calculator for your anti-squat. So I'm gonna show you guys how to measure those kinds of things, and then we'll get back to it and figure it out. So I'm gonna take you guys back to middle school geometry here, and maybe high school if you rode the short bus, but we're gonna turn on our digital protractor. Right on there, nice and flush. We're at about 31 degrees. So with my upper being 31 or so degrees and my lower being just about 12 degrees, that puts me at 43, 44 degrees when you count the decimal places in there. So that's actually within spec and perfect. Now, when we bend down and we look at it from the side, we're gonna use a digital, again, angle finder, take our measurement of the top tube, making sure it's basically parallel with the floor, and then that bottom tube. As long as that bottom tube, that lower, is less than a 10-degree angle, we should be good. Based on that, guys, I mean, that looks like my uppers are pretty parallel and my lowers are definitely less than 10 degrees. So get an angle on those, and we'll plug all that stuff into the 4-link calculator so we can make adjustments just in case I don't like what it sees. Basically, guys, this 4-link calculator here is downloadable for an Excel spreadsheet off of Busted Knuckles website, and you can get it for free. Basically, you have to fill out all sorts of information in here. You got to put in your vehicle's wheelbase. You got to put in your rear track width. Obviously, we're doing our rear suspension, so that's kind of important. You need to put in how, essentially, you know, what your tire diameter is, but remember your measured diameter. You need to put in your vehicle's estimated weight and the rear unsprung mass. Your rear unsprung mass is basically just everything that's under your springs. So your tire and wheel combination, your axle combination, what that weighs, and half the weight of your rear drive shaft. All those things can basically be figured out or estimated to be really, really close. And that's gonna help you. You're also in here gonna have to come over on this side and tell the calculator that you have how many upper links you have, because it can calculate for you with a 3-link. We obviously put in that we have 2. My up travel, that's my estimated up travel. I'm putting in a 16-inch coilover, so I figure with bump stop, that's kind of where I'll have for up. This is kind of what I'll have for down with a limit strap. And then you come in down here where you have to basically start putting in your measurements. So the first measurement, we're gonna start with the rear upper links. We're gonna go with the frame end. Now, if you hover over the box, because you're not sure what that means, it'll basically tell you that you need to go forward from the rear axle center line, obviously, to the frame bracket. Center of the axle tube is kind of basically center of my truss, all the way up here to the center bolt hole. We're basically at 38 inches. So we're gonna come in here, we're gonna tell it that we have 38 inches. Then the next box on the frame end is basically the width. So we're going to the frame brackets once again, and this is half the width of your upper link horizontal separation. Upper link mount to upper link mount on the frame, figure out what that is, divide it in half, throw it in there. My upper link to upper link was 26 inches. Half of that is 13. And again, at the frame end, we're now gonna talk about our height. So essentially, it's where your bracket is off the ground. My measurement is 29 1/4 inches. Axle end lengthwise. Basically, they want to know where your axle bracket is forward from the rear axle center line. We're going to look at those upper brackets. Mine, I believe, are directly on top of the axle center line, so I would say it's 0 inches in front of it. If yours happen to be behind it, I doubt they are, but if they happen to be behind it, you would just put a negative number in there. And if they're, let's say, 1 inch in front or a 1/2 inch in front of that center line, well, that's what you would put in there. We imagine an axle center line basically come up. Yeah, we're basically right on the axle center line. Now we're gonna go to the width. Now this is half the width of your upper link at your horizontal separation. Basically the same thing we did with the frame end, where you measure between them and then you divide that number in half. Center to center. And I am basically at 5 inches. We're gonna call it 2.5. The 4-link calculator is very easy to use. It can be a lot of information presented in front of you, but like I said earlier, hover that mouse, it tells you exactly what to do. When you're done with all the information for your uppers, you're basically gonna repeat the process for your lowers and then check out your auto-populated anti-squat number. They give you a lot of information about what your anti-squat numbers are, right? They give it to you at your up travel, they give it to you at half your up travel, ride height, and at down travel. I don't care about any of that stuff. I'm basically just looking at my static ride height anti-squat, and I'm at 91%. I'm really happy with that because of what I plan on doing with this Jeep. Now, I know my JKU outside has more than 91%, and it rock crawls really well. I'm looking for a balance between speed and rock crawling, and I think 91% is gonna work just fine. So as you can see, I've already pulled out all of the PVC links that I made, the temporary ones. I'm gonna transfer those over to tubing. So I'm gonna show you guys real quick how to make one. I'm not gonna show you how to do all 4. It's basically the same process. You need to make sure that you have enough thread inserted into your heim for it to be safe. Typically, you want the diameter of the threaded shaft going into the bung. You want that much length in there. This one is actually 1.25 inches, so I set it at 1.5 inches. I don't want to set it at the minimum because then you can never make it longer, adjusting your pinion angle or potentially fine-tuning your wheelbase. Now the measurement I'm gonna take is gonna be from the center of the bolt hole to the point where your tubing inserts, to this little crease mark right here. And on this, it was actually 3 3/4 inches, which means that 3 3/4 inch times 2 is 7.5 inches. So I'm gonna take my overall length, bolt hole to bolt hole, subtract that 7.5 inches, cut my tubing at that length, but there's also a trick to weld it up to make sure that it is super strong. So let me cut some tube and get right back with you and let you know what you gotta do so that you can make that strong too.
A few moments later.
Now I did grind the edges in preparation for welding, but I also beveled a 45 or so degree angle in here on both ends. That will allow me to weld these in a specific way to make sure that they are super, super strong. I'll get to that when I show you, but first, I'm gonna drill a couple of holes through the end of each tube, two, basically opposite each other. I can then plug weld into this surface of the bung that goes in, as well as weld it all the way around. We're just gonna slide this end into the tube all the way up to that seam that we measured from before. There's gonna be another one for the other side that's reverse threaded. You wanna pay attention to that and make sure that you use that. That way, all you have to do is loosen jam nuts, rotate the tube, and it will get longer or shorter on both ends. Now that we're in there, you can see we have a nice big gap in here to weld, almost too big. So the first thing I'm gonna do is basically put a weld in here, fill that hole with weld. With those plug welds nice and cool, what we're gonna do is basically lay a root pass all the way around this. So just a base pass down in the deepest crevice here of this joint to kind of help weld it together and bridge that gap. As you guys can see, that root weld did a really good job of gluing those together along with those plug welds. Now we'll finish weld it over the top, making sure that it looks nice all the way around. I don't have anything here like a lathe that's gonna turn the tube as I weld it. I'm gonna try to do it in thirds. So I'm gonna work my way around in a third, roll the tube, and continue working. It's not as pretty of a weld with those start and stops in there, but it'll get the job done just the same. All right, guys, and after all the painting and everything else, I don't know whose bright idea it was to paint these white, but gonna have to do something with some nuts in there. Right now, just have the bolts slid through, but everything's there. My uppers are parallel to the ground. My lowers are actually at a 6.5 degree angle now that I went from the PVC to the tubing. And everything is good. Axle is square. We got good triangulation in there. So guys, this thing is about ready to hit the trail. I'm just kidding. It's not ready at all. Not even freaking close. But stay tuned because I'm gonna do a video on the front axle like I mentioned earlier in this video. We're gonna do that pretty soon and we're gonna get it going. Anyway, guys, thanks for the support. Make sure you subscribe, send this to your friends. Leave a comment below. Let me know what you think. Like I said, if you have any advice, and we're gonna move it on.